Hello students, my name is Manu Singh and I'm going to teach you computer network subject. Today's topic is multiplexing. So what is multiplexing? It is a technique used to combine and send multiple data streams over a single transmission medium. So the process of combining the data stream is known as multiplexing and the hardware used for multiplexing is known as multiplexer. So why we use multiplexing? Because when multiple signals shares the common medium, there is a possibility of collision. So to avoid such a collision, we use the concept of multiplexing. So in multiplexing, there are two devices known as mux and demux. Mux is available at the sender side, whereas demux is available at the receiver side. Mux, which is available at the sender side, combines n input lines to generate a single output line. It is also known as many-to-one approach, whereas demux, which is available at the receiver side, combine one input line to generate an output signal. It is also known as one-to-many approach. Concept of multiplexing. When the n input lines are transmitted through the multiplexer and multiplexer combines the signal to form a composite signal. The composite signal is passed through the demultiplexer and this demultiplexer separates the signal to the component signal and transfers them to their respective destinations. Advantage: more than one signal can be sent over a single medium and the bandwidth can be fully utilized. So what are the techniques of multiplexing? It is frequency division multiplexing, wavelength division multiplexing, and time division multiplexing. So time division multiplexing is again subdivided into two parts: synchronous and asynchronous time division multiplexing. So what is frequency division multiplexing? It is a technique in which the available bandwidth of a single transmission medium is subdivided into several channels, means into several frequency channels. It is an analog technique. In this diagram, a single transmission medium is subdivided into several frequency channels where each frequency channel is given to different devices. The device 1 has a frequency channel of range 1 to 5. Likewise, device 2 have a range from 7 to 12 and device 3 have range from 14 to 19. So the input signals are translated into the frequency bands by using some modulation techniques and they are combined by the mux to form a composite signals. So what is the main aim of FDM? The main aim of FDM to subdivide the single bandwidth into different frequency channels and allocate them to the different devices so that simultaneous transmission can occur. Here is a diagram. Here there is a input signals, that is source 1, 2, likewise source n, and modulator F1, F2 and Fn. These are called subcarriers, means they are called subsignals. These are used these carriers, the carriers which are used for modulating, right? The signals are known as subcarriers, right? So FDMs are basically used in radio broadcast and TV networks. So advantages are: it is used for analog signal, very simple and easy modulation, and large number of signals can transmit simultaneously and doesn't require any synchronization between sender and receiver. Disadvantage: is used only when low speed channels are required. It suffers the problem of crosstalk. What is a crosstalk? Means the mixing of the different signals. A large number of modulators are required. It requires high bandwidth channel. Application of FDM is used in TV networks. It is also used in FM and AM broadcasting with different frequencies. Now what is wavelength division multiplexing? Wavelength division multiplexing is same as FDM except the optical signals are transmitted. right? It is again an analog multiplexing technique. Here, optical signals from the different sources, they are combined to form a wider band of light with the help of mux. At the receiver end, demux separates the signal to transmit them to their respective destinations. So their mux and demux, they are achieved by using the prism phenomena. Understand? Now what is TDM? It is a digital technique. TDM, in TDM, the signals operate at the same frequency with different times, right? Means the total time available in the channel is distributed among different users. Therefore, each user is allocated with different times intervals known as time slot at which the data is to be transmitted by the sender. Right? In TDM technique, data is not transmitted simultaneously. Rather, the data is transmitted one by one. There are two types of TDM, synchronous TDM and asynchronous TDM. Now, in the synchronous TDM, here's a diagram of synchronous TDM. In the synchronous TDM, where the time slots are pre-assigned to every devices, and each device is given some time slot irrespective of the fact that the device contain data or not. So the signals are sent in the form of frames. So time slots are organized in the form of frames. If the devices doesn't have data for a particular time slot, then the empty slot will be transmitted. So the most popular examples are T1 multiplexing, ISDN, and SONET multiplexing. If there are n devices, there are n slots. In this figure, a synchronous TDM technique is implemented. Right here, the first frame, that is A, B, C, is transmitted. Second is A, B transmitted, and third is A transmitted. In the second and third frame, some slots are free. There is no data in that slots. What is a disadvantage? Disadvantage is the capacity of the channel is not fully utilized as the empty slots are also transmitted, which is having no data. In the last figure, we have already saw, right? Like ABC, first frame fully transmitted, second and third frame it is partially transmitted. Partially means some of the slots are free. The speed of the transmission medium should be greater than the speed of the input line. This is the another disadvantage. Means the alternative approach of the synchronous TDM is asynchronous time division multiplexing. Now what is asynchronous? It is also known as statistical TDM. Asynchronous TDM, in which the time slots are not fixed. Time slots are allocated only to those devices which have data to send. Right? Means TDM transmit only the data from their active workstations. Right? The total speed of the input lines can be greater than the capacity of the channel. And asynchronous TDM accepts the incoming data stream and creates a frame that contains only data with no empty slots. So each slots contain an address part that identifies the source of the data. Means every slot have the address part, source address, destination address, so that it can identify the source as well as the destination. The difference between these two means the synchronous, asynchronous. Synchronous, they are unutilized, and in asynchronous, the slots are utilized. Right? In synchronous TDM, there are n slots, and asynchronous, there are m slots, where the m slots is always less than n slots. The number of slots in the frame depends on the statistical analysis of the number of input lines. So in this diagram, there are 4 devices, but only 2 devices are sending data, that is A and C. Therefore, the data of A and C are only transmitted through the transmission line in case of asynchronous TDM. Right? Thank you very much.